Topic of the day is systems of inequalities. If you remember when we talked about system of equalities, we were graphing pretty much two figures and finding their intersection. When we talk about system of inequalities, we're talking about a range of answers, not a specific answer. So we're going to do some shading, and when we shade, we'll have a region in which our solution exists. So let's go ahead and do a simpler problem, very similar to Algebra 1 type thing. We have to solve the system of inequalities here. I want to take and graph each of these two lines. I'll put them in slope-intercept form, and I get 2x plus 4 is less than or equal to y, and then I get y is less than or equal to negative 3x minus 1. Moving over to the graph, we go up to 4, rise 2 over 1. Connect all those dots. Here's our line. And now we have to shade. What I prefer to do is pick a sample point and see if the sample point is a solution for the inequality. I usually go with 0, 0, and then check to see if that works out. So if I plug 0 into x and 0 into y, will I get a true statement? 4 then would be less than or equal to 0. That's not true. It's false. So what that states is this point 0, 0 is not in the solution region of this inequality. So I have to go to the other side of the line and shade that. Next, let's go ahead, go down to 1, go down 3 and over 1. And draw my graph once again. Use 0, 0 as my sample. And I get 0 less than or equal to negative 1, which is also false. 0, 0 is on this side. I shade the other side. And now I have a situation where I have a double shaded region, which is right here. And that's my solution for this system. They call this area where both maintain a true solution feasible region, which means that any solution in this region will work for both of the equations in the system. So now we go nonlinear. We have a parabola here, and this is really an HK form. I've got negative x squared plus 9, so I know I have a translation of 9 up, and then a parabola moving downwards. So I'll go up to 9, go down 1 over 1, down 2 over 4, 3, 9, and I get a parabola. I'll still take in this problem and go ahead and pick a sample point of 0, 0. Doing that, I get y is, get 0 is less than or equal to 9. And that's a true statement. So since this 0, 0 is less than or equal to 9, I shade inside that parabola. Moving to this next line, I get y is greater than or equal to x plus 3. Go up to 3, rise 1 over 1. Draw the line, pick my sample point of 0, 0. 0 is greater than 3, not true. I shade. Up. And then I have y is greater than 0, which puts me y equals 0 on this horizontal line. And then I shade above that because that's where the y is equal to 0. and you'll see that my triple shaded region would be inside this parabola and enclosed by the line. Let's continue. We have y is greater than or equal to x. Well, y is equal to x is here. I can't pick 0, 0 because 0 is actually on the line, so I pick another point. I can pick 1, 0 for my sample, which means 0 is greater than or equal to 1, which is false. Here's 1, 0. Go to the other side, which shades me here. Y is less than or equal to 5. It's a horizontal line. And y is less would be below. And then I have 2x plus 3y is less than or equal to 6. I can get the slope intercept form, or I can use x and y intercepts, and I think I'm going to do that. If x is equal to 0, then y is equal to 2 in this case. And if y is equal to 0, then x is equal to 3. So once again, this is my y-intercept, this is my x-intercept. Sometimes it just makes it a little quicker to go ahead and approximate values. So 0, 2 is right around here, 0, 3 is down here. I'm going to go ahead and connect those dots. And once again, pick a sample point of 0, 0. So in that case, if I pick 0, 0, I get 0 less than or equal to 6. True. So I shade towards 0, 0, which gives me a triple shaded region. In this area here. And now we've got a circle and a line. So let's go ahead and graph that. We've got a circle translated down 4, or I'm sorry, up 4. Has a radius of 3, so I go 3 up, 3 to the right, 3 down, and 3 to the left. Connect those dots. Might as well pick the point 0, 4 inside. I can pick 0, 0, really doesn't matter. But I'm going to pick 0, 4 in this case. So I would get 0 is greater than or equal to 9, which is not true. So I'm shading actually outside of the circle. And then once again, I'm going to use intercepts. If I set x equal to 0, y value is 2. If I set y equal to 0, my x value is 6. And then I can go ahead and graph those points, connect those dots, and test the point 0, 0. I get 0 less than or equal to 60. It's true. So I shade down this way, and my double shaded region would be everything below that line, but not the little portion of the circle. And lastly, we're going to use 3 equations, actually 4, because I have x is greater than 0 and less than 15. I use intercepts once again. Here's 0, 20, 20, 0, 0, negative 3, and 2, 0. Let's go ahead and graph all these. There's 20, 20, use my sample point of 0, 0, and I get 0 is less than 20, which is true, so this would shade down. Here is x is equal to 0, and x is equal to 15. It's here. Shade between the two. So, and then at 0, negative 3, and 2, 0, and then I graph that. This is going to be averagely accurate because I haven't really checked all the way up. So the next thing they want me to do, after I finish shading this, I use 0, 0 again. So I say 0 is greater than 6, which isn't true. So I shade the other side, which means my triple shaded region in this case is this area here. And they asked me to find the corner points of the feasible region. Now, corner points are big, they're also called vertices. Are points of intersection, like so. So a couple of these are pretty easy to find. I know I have an x value of 15 intersecting this first line. So if I know x is equal to 15, I have 15 plus y is equal to 20. So y would equal 5. So one corner point is 5 and 15 and 5. I have this point down here where I know x is equal to 0, and that's intersecting this blue line, which is the third guy. So 0 minus 2y is 6, and y is equal to negative 3, which we already knew. And then finally we've got this intersection here, which is the intersection of the first line and the last line. For this I'd have to do a system. So I can multiply the top equation, let's say by 2, giving me 2x plus 2y is 40. Add that to 3x minus 2y equals 6. End up with 5x equal to 46. Yep. So that's 46 over 5 is equal to x. Then I'd have to plug back in to get y, and y ends up equaling roughly 54 over 5. So this point, once again, right here, is going to be 46 over 5 and 54 over 5.